Welcome to a lesson with Dr. Powell. A polynomial, when we're thinking about its graph, is going to look a lot like its leading term. Its leading term is like the term that has the highest power of x in it. So suppose you have something like x cubed and 2 plus 3x minus 5 or something like this. So the term that has the highest power in it, this is called the leading term. And the coefficient right there, that's called the leading coefficient. So if we're going to be thinking about the way these things graph, we really look at the leading term, because far away, let's just think about what happens. What's the ratio of this to that when x is very large? So 3x minus 5, how does it compare to 2x cubed? Well, it's zilch, really. Think about, just think of plugging in some big numbers and see. This is like you plug in 100 here. This is going to be like 100 to the third power down here. Well, that's gigantic compared to just plugging in 100 right here. And in general, that's true. The leading term is always much bigger. So if you go far away enough out and zoom out like in outer space or something, you won't even see the effects of this part. You really only see that part. So if this graph looks something like that, and you could plug in your calculator or something to see what the leading term is, then that is what it looks like as a graph. Then this is what the graph is going to look like ultimately far away. We have kind of a way of notating this, of what the graph looks like when it's far away or talking about it. It's called end behavior. So when so for instance, if I have a polynomial function such as 5x squared minus x plus 3, I just look at the first term. Now the first term, or the leading term, tells us the way it graphs. This is just a parabola pointing upward. On the ends, it looks like we're going to be way up on this end and way up on that end. So we say the end behavior for this particular polynomial is up, because it's up on the left side and it's up on the right side, going up forever way up and forever way up as we go out this way or as we go out that way. Now, what about the end behavior of something like this? Negative 5x, let's do x cubed, plus 3x minus 7. Now, the graph of an x cubed function looks like this. If you make it negative, it actually looks like that. So the end behavior of this particular function just follows the leading term itself, and it'll be up, down. When in doubt, you can always just graph leading term and see, or here's another idea. What if we just think of what happens when we plug in a really big negative versus what happens when we plug in a really big positive? It'll tell us whether we'll be up or down. Notice here, this whole part, this is just positive cubed times 5 and then a negative, and the whole result will be negative, which means that on the right will be down. Now what about on the left? Well, let's see. If you have a negative to the third power, like 3 negatives, and then you have another negative, that's going to be positive. So you're going to be up over there. So up, down. So even without knowing the graph, you should be able to detect what the end behavior is this way, up, down in this case. So what about if we had 5x to the 7th power? What's that end behavior? Well, again, let's just think about this. We have on the right, we get positive, a really big positive number versus a really big negative number. What's happening? We have 7 negatives. That's going to result in being negative. Over here, just all positive. So, your end behavior is simply going to be down on this side for the negative and up for the positive over here. So the end behavior will say, reading going from left to right as down, up would be the end behavior of of a polynomial where this would be the leading term. Thanks for watching.